Hello and welcome to this episode of Math with Martinez. We are in our unit on quadratic relations, equations, and inequalities. And throughout this video, we're going to be learning how to solve quadratic equations by taking the square root. So let's get started. Equations of the form where we have x squared minus c equal to 0. In which C is one of our perfect squares, like 1 or 4 or 9 or 16 or 25, all those perfect squares, right? If C is one of those perfect squares, then we can use factoring like we saw previously. However, if C is not a perfect square, then factoring is not going to be a method that we can use. We're going to need another method. We won't be able to complete our area model. So to solve equations of this form, the first thing that we're always going to want to do is isolate the squared expression and then take the squared root of each side of our equation. Let's look at this first example together. If we're going to solve x squared minus 81 equals 0, then the first thing is to isolate the squared term. How do we do that? We need to do the opposite operation here because our squared term has 81 being subtracted. I need to add it on each side, and that will give us x squared equals 81. Then we will want to take the square root of each side. So I'll take my x squared and I'll take the 81 and I need to take the square root of each side. Now remember, step number 3, that the square root of x squared, the square root of x squared is actually just the absolute value of x. And remember that the square root of 81, right, is a perfect square. It is 9. Then we apply our square root property, which says that if x squared equals k, then k is going to have two possible answers, both the positive and the negative. Think about it this way with me. What values make this true? What are the values that when we take the absolute value of x give us 9? Well, there's actually 2. It is both positive 9 and negative 9. Both those values make it true. So what we often will do is we'll skip from here to here and say that the square root of 81 is both positive and negative 9. Catch that with me again. Positive and negative 9. This is how we write that we have those two values. That's going to be the notation that we use with that little positive and negative sign in front. So let's do another. We are going to solve 3x squared minus 100 equals 0. Step number 1, make sure that you isolate your squared expression. Right now we have 100 being subtracted, so I need to do the opposite and add 100 on each side. That gives me 3x squared equals 100. And then I need to divide by 3. Let me actually do that in red. Divide by 3, and that's going to give me x squared equals 100 divided by 3. I then need to go ahead and apply my square root property, and in doing so, what I'll have is that if I'm taking the square root of each side, then really what what I'll have is x is equal to both the positive and negative square root of 100 over 3. All right, so that's that application of our square root property. If, let me highlight it here, that square root property says if x squared equals k and k is greater than 0, then x is both the positive and negative square root of k. So that's what I did there. Now, we need to finish by simplifying our radical. This is not a perfect square, so we need to go ahead and simplify it. Because I have a numerator and denominator here, what this really means is that I'm taking the square root of 100 and I'm taking the square root of 3. I'm taking the square root of the numerator and the denominator. However, we cannot have a square root in our denominator, and therefore we need to rationalize our denominator. In order to rationalize our denominator, what we're going to want to do is multiply top and bottom by the radical that will make the radicand in the denominator a perfect power. That would be to multiply top and bottom, in this case, by the square root of 3. Now, why would I want to do that? Check this out. I'm going to highlight what happens in red. What I have here in the numerator is the square root of 300. Oh, wait, no, the square root of 100. Ooh, I can simplify that. What is the square root of 100? That's in the numerator. It's a 10. And then what else is up there? A square root 3. And then I have my square root of 3 being multiplied by itself. That is that it is squared. That's that perfect power. I'm squaring my square root. So what does this simplify to? What does this simplify to? Ladies and gentlemen, it is simply 10 square root 3 over 3. That is our simplified radical response. Okay, so that is solving using square roots, taking the root on each side. But what if we come across a problem like this, where instead of subtracting a constant, we have something like our squared term adding a constant? If we were going to take the square root, then this is what will result, right? What would I have to do? I'd have to subtract 1. So then my equation looks like x squared equals -1. If I take the square root on both sides, apply that square root property, I'm taking the result to be the positive and negative square root of -1. Now, we all know that there is not a real number that will give us any kind of negative result, right? There isn't a number that when I square it gives us a negative output. Well, not a real number. There's not a real number. This right here is designated as imaginary. Now, there is a mathematician, his name was Leonhard Euler, and he first started using this I to denote the square root of -1 in 1777. And so this leads to our definition. The imaginary unit I is the square root of -1. So that I is the square root of -1. And if you took I squared, it is -1. So the solution to the equation x squared plus 1 equals 0, it would not be written like so, but it would rather be written as positive and negative I. That is the solution to this equation. And the square root of other negative numbers are expressed in terms of I. We are going to see an example down below. So before we look at that example, just a really important synopsis that I want us to be aware of is right here. This is our square root property. Our square root property says that if we have x squared equaling some k value, some constant, there are three different kinds of results. If our k is greater than 0, then we'll have two real solutions, positive and negative square root of k. If our k is equal to 0, then we'll have one real solution, 0. If our k is less than 0, then we'll have two complex solutions, which will be I square root k, positive negative I square root of k. Okay, now let's look at how does that play out? Well, let's solve x squared plus 45 equals 0. Like we did before, isolate the squared term, subtracting 45 on each side so that we have x squared equals negative 45. Apply our square root property. Which is, if I take the square root of each side, in this case, it's not, I made a little typo here. If what we have is actually that our k is less than 0, you see how our k value is less than 0, then what we will have is not just square root of k, positive negative square root of k, but positive negative I square root of k. And that k, we're going to want to take the absolute value of it. So what does that look like here? That looks like I'm going to have x is equal to, from this step on, I'm taking the square root of each side so that I have x equals, I'm taking the square root, so I'm going to have both the positive and negative. Because it's negative, I'm going to go ahead and implement the fact that we are working with an imaginary unit here with I, and then square root of the k value, that constant, 45. That's the absolute value of that radicand. Okay, now, can we simplify the square root of 45? Earlier this year, we looked at simplifying radicals, and so we would ask ourselves, okay, is there a perfect square that is a factor of 45? Is there a perfect square that's a factor of our 45? Yes, there is. It is to multiply 9 and 5 together. 9 is that perfect square. So what I have here is the square root of 9 and the square root of 5, but the square root of 9 is 3. So I have I times 3 times square root of 5. The way that we will often write this, the best way to format this is to go ahead and put the 3 in front of the I, and then the radical at the end. That is going to be the way that we should format our final statement. So ladies and gentlemen, there you go. That is solving by taking square roots. We see that it is a really good approach when you cannot solve by factoring. And sometimes what you're going to realize is that your solutions might not be real. You might, in fact, have complex solutions. That's going to occur if your k is less than 0 when it's written in this form. If you had any questions, take a moment and share those right now. And until next time, stay fired up, you guys.